Hello, in this video I will talk about a short program that I wrote to help me calculate the roots of a quadratic equation. I needed something to help me calculate the roots of quadratic equations very fast and easily, because in my assignments I had many quadratic equations that I had to calculate, and it was taking a lot of time using paper and pen. So why not use Python? And I used the Wing 101 platform to do this because I find it easier and more, I'd say, coder friendly than the Python shell itself. So basically in this area you write your code, and in this area you execute your commands, and you can also open files from your computer, Python code that you already saved from your computer. Using this you can figure this out. You can save from here and all this stuff. Just play with the buttons and you'll figure it out. And another thing is that the Wing 101 platform and Python itself, it's all free, so you can go to the Python website and download the software. So the first line, okay, and in the command prompt also you could also execute short commands like 9 plus 3 12. So you can do quick calculations down here, and you can also test stuff out here before you use them in your program, so you know how it will perform in your program. So the first line of the code says import math. This basically imports the math module from the Python library and opens it so that you can use it down here in your program if you wanted to use it. And the second line says equation equal to input, enter quadratic equation carefully in the form this. So when you run this program, this statement in green appears in the command prompt, prompting the user to enter the quadratic equation in this form. So, and when the user enters the equation in this form, Python saves it as equation, and it will be a string. It will be saved as a type string. Type string is basically letters and characters. Numbers is typed in or type float, and type float is numbers that have decimal places like 5.1, 5.2, and integers is just type int. Those are some few types in Python. And the third line says a equal to float equation. This equation bracket 0 till from 0 till equation find x. So what this line does is it converts the number that it finds into a float, and the number that it finds is from the starting index 0. The starting index is this index. When Python saves this, it saves it as a string, right? So the first index is 0, the second index is 1, the third index is 2, and so on. So it cuts out the first index from the first index till the index before it finds x, before it finds the character x. So it cuts out everything from the beginning till x without x, and it converts that into a float, which is a number that has a decimal point, as I said. And it does the same thing in B. So B also, it cuts out the number from where it finds the plus sign till actually plus 1, so it doesn't include the plus. So it cuts out all the characters from after plus till it finds the last x. So equation.r find x, it means you should index till you reach the last x in your equation, and basically this is the last x in the equation. So it takes all of those numbers and convert them into float too. So C also cuts out this C, which is basically any character from after the last plus sign till the end. If you just put a colon, right, it takes it till the end. And basically you don't need to put these print statements. I just put this print statement so that I confirm that Python has taken out what I want. So it has taken out A to be this, the first number, B to be the number here, C to be the number here, and then now starts the calculating of the quadratic equation part. So D is equal to B squared minus 4AC is the discriminant of the quadratic formula. You remember the quadratic formula, x is equal to negative b on a plus and minus square root of b squared minus 4ac, all of that divided by 2a, right? So the number under the square root sign is called the discriminant, and it is b squared minus 4ac. So it calculates this number and it stores it as d. Then E1 is basically negative b over 2a, which is the first part of the quadratic formula, the roots on the quadratic formula, and it stores it as E1. So E2 also is math dot square root of absolute value of d divided by 2a. So it takes the last part after the plus and minus sign. It calculates that it takes, even if d was negative, right, it takes it as a positive number and calculates the square root of that and divides by 2a to get the second part of the solution in the quadratic formula. And down here now I used if statements to split up the types of roots in the quadratic equation. So if d was less than 0, you remember from the calculus classes, then the roots are complex. If the number under the square root sign is negative, then the square root of a negative number would be a complex number, right? So it would be something root I. So basically then you print out this statement, basically prints the answer out. If d was less than 0, it prints out the characters x1 equal to, so it just says a statement x1 equal to, then plus is just for Python to understand plus, you print out this other thing, string e1, convert this e1 that you calculated up here back as a string, then you print it out after the equal sign, and then you print out plus, and then you print out e2, and then you print out I. So I now to say that the number is a complex number. So because I represents a complex number, I know for electrical circuits, because current is I, they use J. So I'm in mechanical engineering, so I use I because I don't have many stuff where I used I. Then this this backslash n basically takes the print statement to the next line. So after it has printed all of these things in one line, it goes to the next line and prints x2 equal to, then it prints the same thing as here, the value of e1, which is negative b over 2a, then minus, you know, it was positive and negative, square root of all of those other stuff behind, right? So this is the negative part, minus, it converts the value it got here as e2 into a string and prints it out, and then prints an I behind that. And if d was equal to 0, you use elif d was equal to 0, right, to say this is like a different thing. If this was what happened, then you print, because if this was what happened, you will have equal roots, right? So you print x1 is equal to x2 because they are same, which is equal to, you convert the number you got into a string, then you print it out. And then if elif if d was greater than 0, you say elif d was greater than 0, same thing up here. Then you print e3 is equal to e1 plus e2, and e4 is equal to e1 minus e2. Then you print the stuff down here. You calculate this. These two lines of code calculates this, and this line of code prints it out in the command prompt. And then if all of this up here did not happen, then print enter equation correctly. So Python will prompt you to enter equation correctly if you made an error and something happened and all of these three scenarios did not happen. I know it's hard. This is just like a safety feature or something, like to tell you that something has happened. You should print, you should write out the equation correctly. So I'll go ahead and run this program and test it out. So let's see. It's run. So I'll copy this, so I'll have it in the same format, easily Control C, then I'll print it here, then I'll change this A, B, C to numbers. So I'll put this, any number you want, even a huge number, whatever, Python will do it for you. This. Then you press enter to get the answers. So you see what Python has done. You remember these print statements up here, which are not really necessary. So this prints B. It first of all prints A. A is equal to this number here that we cut out, and the second thing that it prints is B, which is the second number that we indexed right from up there, and C, it also prints it, and then it then calculates x1 and sees that it is a complex number. So this was what happens. D was less than 0 in this situation. So it then prints out the first part E1 plus the stuff under the square root sign times I, which is basically the square root of -1, and then it does it for the second part, for the second root. Quadratic equations have two roots, so it does it for the second root with a negative sign. That. So let's try another equation where it will give us not complex roots. Let's see. If this is 1 and this is 3 and this is 2. So basically factors of 2 that will add to give 3, 2 and 1. 2 times 1 is 2, 2 plus 1 is 3. The roots are supposed to be -1 and -2. There you go, it gives you -1 and -2. So it indexes A as 1, B as 3 and C as 2, and then it calculates the roots. The roots are -1 and -2. Let's try an equation that will give us equal roots. So if we have, let's say, 4 factors of a number that will add to give, okay, let's say 4 here, and we have 4 here, and we have 1 here, because you know 2 times 2 is 4, right? And 2 plus 2 is still 4. So this will give us equal roots. So you see, Python says this is A, this is B, this is C, and then x1 is equal to x2, which is equal to -2. So that's it basically. Python is lovely. So thank you for watching.